Hello everyone, this is Professor Nelson from Electronics. Today we're going to talk about a component commonly used in equipment that operates at high temperatures. These components are called thermal fuses, and they function similarly to regular fuses that operate based on current. They perform the same function: opening the circuit or protecting the device or equipment when the conditions specified by the fuse are met. Traditional fuses only work with one parameter, which is the current. And if the current exceeds the limit set by the fuse, the traditional filament fuse will open the circuit and protect the equipment. However, a thermal fuse has two parameters that can be met independently. The first and most common is current. Voltage is not used as a parameter in this case. It can be used at 12 volts or 24 volts. The important parameter is the current. In this case, if it exceeds 10 amps, the fuse will blow. But the important thing about this fuse isn't the current rating, but the temperature. Thermal fuses have a specific operating temperature. So, if that temperature of 150 degrees is exceeded, in the case of this fuse, the circuit will open. In other words, the fuse will burn out and no longer work. It is single-use, just like the fuse that you find with a glass encapsulation. We have them in different temperature ratings. Therefore, you need to choose the right one for the equipment or the replacement you are looking for. Here I have another 10 amp fuse, but rated at 170 degrees Celsius. And like a normal fuse, this one doesn't have polarity, so it doesn't matter which way you put it in. Therefore, don't worry about the orientation. Now, to test a fuse, we need our multimeter, which we usually have to set to continuity. They put it there for those who like the multimeter to beep. Personally, I don't like it to beep much, especially since it's the same as measuring in ohms. Continuing, first check the probes. We put it in resistance. It must mark them that way, and then they measure the fuse. They should register the same value, provided they are making good contact. It will stabilize there. There shouldn't be much difference. Now this means it's a fuse that's in good condition. Let's test the other one. As I told you, this has no orientation, so it doesn't matter which side you measure it on. The important thing is that we have continuity. There we have continuity. However, I have one that's damaged. And as you can see, it doesn't measure. It should read 0 ohms. And like a traditional fuse, when the temperature reaches the value indicated on the thermal fuse, or rather, exceeds it, the fuse will be completely damaged. It doesn't necessarily have to burst its casing. The fuse burns internally, and the equipment will stop working. Now, when you look for the fuse, you might not find it. That's because the fuse is usually hidden inside a metal plate, which is typically embedded in the equipment's cabinet where it's heating up. And it is usually contained in this type of fiber that withstands high temperatures. It's usually inside, so it's difficult to know where the fuse is. And even worse, this is often placed on top of a metal cabinet so that the heat can be transferred to it. And that's where it's hidden. Therefore, if you find these types of metal cabinets and this type of fiber, that's where the thermal fuse is located. And perhaps they can't find it because of that. The temperature in the case of the fuse tends to be slightly lower than the desired cutoff temperature due to the metal casing. The fuse's metal casing creates a temperature difference compared to the temperature of the area being heated. And apart from that, the fiber will also cause another temperature difference to appear. Therefore, the temperature will not be the same as the cutoff temperature in the area of the equipment being heated. Let's assume we have an oven that heats to 200 degrees. We're not going to buy a 200-degree fuse because there's a loss of temperature in the sheet metal and the fiber. Therefore, a fuse with a temperature slightly lower than 200 degrees Celsius is always sought. Well, that would be all, but before that, let's test it with a light bulb to see if it works. Although a multimeter should be sufficient. Here we have our thermal fuse connected like a traditional fuse, which will allow current to flow to the light bulb. And the other end of the light bulb will be connected to negative. The bulb should light up if the fuse is in good condition. And again, I repeat, this fuse doesn't have polarity, so it doesn't matter which way you connect it. You'll find this type of fuse in appliances like microwaves, electric ovens, irons, hair dryers, and water heaters. They're also found in equipment like water heaters. There's a lot of equipment that operates at high temperatures, and you'll find them there, always as protection against high temperatures. Alright guys, that's all for now. Don't forget to like the video if you enjoyed it. A like really helps the channel. See you in the next video. Bye-bye.